Continuing on talking about factoring, we need to talk about the sum of perfect cubes and the difference of perfect cubes. So the first thing that we need to discuss is what is a perfect cube. And a perfect cube are numbers like 1, 8, 27, 64, 125, 1,000. You can keep going forever. But the reason it's called a perfect cube because one number that you can multiply together 3 times and get that number. 1 times 1 times 1 is 1. So 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64, and so on. So when I multiply 4 times 4 times 4, I get 64. So these are some of my perfect cubes. So you're going to need to be able to recognize those when we're actually solving and factoring here. So we have some formulas that we're going to use. You have the sum of cubes is a cubed plus b cubed. That means I have 2 numbers that are variables that are cubes, perfect cubes, and they're being added together. So that's the sum of cubes. If I have 2 things being added together and they're perfect cubes, then when I factor them, here's how I get it. It's the first term plus the second term. Then it's the first term squared minus the first term times the second term plus the last term squared. So the important thing here is to be able to rewrite the problem using perfect cubes. So I know number 1 is already done here, but I want to take a look at how I did it. Number 1, we have x cubed plus 8. I recognize that x is being cubed, so it's a perfect cube, and I also recognize that 8 is a perfect cube. So I'm going to rewrite it as x cubed plus 2 cubed. This tells me what my first term is and what my second term is. And if I wanted to, I could even go to the lengths of saying, well, in this case, A, the first term is x, and B, my second term is 2. And so I can just plug it into my little formula here. It's the first term plus the second, so x plus 2. Then it's the first term squared, which is x, so x squared, minus the first times the second, so that'll be 2 times x, which is 2x. And then finally plus the last term squared, which is 2 squared, plus 2 squared, which becomes x plus 2. X squared minus 2x plus 2 squared is 4. And this would be my factored answer. Example 2, we have 8x cubed plus 27. And really the most difficult part about factoring these cubes, in my opinion, is being able to rewrite this cube in a way that you can recognize what is actually being cubed. What is my first term? What is my second term? So when I do that here, I would rewrite this as, well, I know 8 is a perfect cube, and x is being cubed, so that's a perfect cube. And I know that 27 is a perfect cube. So I rewrite it like this. 2x cubed is the same thing as 8x cubed because of the fact that because I have multiplication inside the parentheses, my exponential rules say, my exponent laws say, that inside here, if there's no power written, then we know that it's a power of 1. And the rule says that if there's a power outside, it has to be multiplied to each power inside, which would give me 2 to the third, which is the 8, and would give me x to the third, which is my x to the third. And so that's how I know that 2x in parentheses cubed is the same thing as 8x cubed. Then I can rewrite the 27 as 3 cubed, because 3 times 3 times 3 is 27. So my answer, when I factor it, becomes again, the first term plus the second, so 2x plus 3 times the first term squared, which is 2x squared, minus those two terms multiplied together, which is 2x times 3, plus the last term squared, which is 3 squared. And simplifying, we get 2x plus 3. 2x squared is 4x squared minus 2x times 3 is 6x plus 3 squared is 9. This is my answer. And example 3, I have x to the third minus 125. I recognize that I have the difference of cubes because x is cubed, and 125 is 5 cubed because 5 times 5 times 5 is 125. So when I factor here, I have the first term plus the second term, which is x plus 5. Then I have the first term squared, which is x squared, minus the first times the second, which is 5x, plus the last term squared, which is 5 squared, which is 25. This is my answer. Let's move on to the difference of cubes. Really quick, I just noticed an error on this. Some of you might have been wondering. This is just a typo here. Just this, make that a plus, making that the sum of cubes. Otherwise, it would have been the difference of cubes. Okay, difference of cubes. It works a lot the same. You have a perfect cube minus a perfect cube, and you're just going to find what the first term is, the second term is, and you're going to plug them into this little shortcut formula, and you'll have it factored. So with example 1, I have x cubed minus 27, and so I can rewrite that as x cubed minus 3 cubed, and so I just plug it in. First term minus the second, first term squared, plus the first times the second, so 3 times x is 3x, plus the last term squared, which is 3 squared, which is 9. And I'm done. Last example for difference of cubes, I have x cubed minus 125, which I can rewrite as x cubed minus 5 cubed. So it's the first term minus the second, which is x minus 5. Then it's going to be the first term squared, which is x squared, plus the first times the second, which is 5 times x, which is 5x, plus the last term squared, which is 5 squared, which is 25. That's my answer. And finally, what we're going to talk about in our review of factoring is a combination of basically all the things. And it's kind of like what I've been talking about at the beginning since we've started factoring. You want to always first, it says here on choice A under combination, first look for common terms. You always want to try to factor out that common term. You typically can get the same answer if it's trinomial factoring, but if you don't factor out the common term on trinomial factoring, like this example 1, if I notice right off the bat I have a common term of 3 that I can factor out. If I don't factor that 3 out, I can still get the same factored answer if I go through the same steps I showed you in the previous podcasts. But if I take out the common term first, it makes life a little bit easier because the numbers that I'll be dealing with will be smaller. And then B says to decide if trinomial or difference of squares factoring can be done, and so on and so forth. So let me show you what I'm talking about with example 1. I see there's a common term of 3, so I would factor out that 3, which means I'm dividing each term by 3, which leaves me with x squared plus 6x plus 8 on the inside. Now I'm going to forget about this 3 just for a second. Just for a second, forget about it, but you have to remember to put it in your answer at the end. Now going back to what I was saying a minute ago, see, before I would have had to multiply a times c, which would have been 3 times 24, which is, a larger number than a times c here, which will be 1 times 8. So I'm dealing with a lot smaller number. It just makes life a little bit easier. So back to trinomial factor we talked about yesterday. We have our signs are going to be the same, and they're both going to be positive. A is 1, B is 6, C is 8. A times C is 8. Looking at the factors of 8, I have 8 and 1, 4 and 2. And if my signs are the same, they're both positive, which set adds to 6? And it's these two, the 4 and the 2. My next step is to divide by A, which is 1. The next step is, can I reduce these fractions? No. So finally, the variable goes with the number on bottom. It's going to be x plus 4 and x plus 2. And don't forget this 3 that you pulled out initially. That's my answer. And then finally, example 2, it looks like, first of all, that I have a common factor that I can take out of 9, because 9 is divisible by 9 and 81 is divisible by 9. So I'm going to pull that 9 out first. 9x squared divided by 9 is x squared, minus 81 divided by 9 is 9. Not quite done yet, because what's left on the inside of the parentheses is the difference of squares. I could rewrite that as, if I wanted to, x squared minus 3 squared. And then remember, the difference of squared is the first term plus the second and the first term minus the second. And I'm finished right there. So hopefully all these review of factoring helped you out. Remember, practice makes perfect.